Hello there. Welcome to this episode of the Shieldia guide where I'll cover the damn vulnerable web application cross-site scripting reflected on low security, a continuation of the cross-site scripting section of the damn vulnerable web application. In the previous installment, we discussed some of the dangers of cross-site scripting within the document object model. However, in this instance, it's directly within the application itself. So within the actual source code of the website, we will have a reflected version of cross-site scripting. This is in contrast to a stored version of cross-site scripting. Instead, here, reflected refers to the fact that if I run the payload, it's going to be reflected back at me. However, if someone else runs the payload, it'll be reflected back at them, as opposed to stored where anyone viewing that particular page, the vulnerable JavaScript would execute. That makes sense. We can exit this, we can close the web server, exit that. We can then once you're logged in and set the appropriate security level to the tests you're running, we can have a look here. On the blog mentions some prerequisites. You're going to need those if you want to follow along at home with exactly the methods I'm describing to you today, the red team perspective and the blue team perspective. You'll note, as opposed to the DOM, there are actual logs for this activity within the seam. So we are able to create detection logic, thankfully, for this instance. As I state here, the undocumented exploit in the file inclusion is a reflected type of cross-site scripting, because we pushed our user agent to the web server and then it reflected that back at us. If in any instance you see that, if it can be tampered with and it's not properly sanitized, it could be injected. We are then given within the basic browser a input area, so input type text, as opposed to a multi-line, which would be text area. Don't need to worry about that too much at the moment. Instead, we could put ASDF. We'll say hello ASDF. So it's echoing or reflecting that name back at us. See here, name equals ASDF as the variable for that parameter. Very interesting. Can we then abuse that? Yes, we can. We put the classic script alert1 script tags that will then be reflected back at us, and then we will see this alert. That's great. That's great. Cool. This is just the classic. Now we can move into something a bit more complex, which is a ffuf default, because of its limitations in regard to actually running JavaScript. We can augment that with a Python script. As is mentioned here in this information box, there are a few problems you'll run into when you tried this at home, depending on how old your Kali instance is, and then depending on a variety of other factors. But for now, actually it's this information box, that's the main one. For now, we'll have a look at this one. It's merely mentioning the fact that we want to encode all of the payloads that we are trying. This is because a lot of the payloads aren't URL safe, so therefore it will fail, and its failure is a bit less obvious in this instance due to how Elastic is hoovering up the data, which will be discussed in the blue team section, or at the end of this section. We can then use this command to execute and test some of the payloads against the parameter that we are injecting. What this command is doing, again, so this is actually against the file inclusion. So we would want to change that to our actual target today. We're not going to worry about that. In this instance, parameters of the Python will be checked. Okay. So instead, we'll make our directory. We will save that just there. Make the directory. Get the PHP session ID. So I've got the PHP session ID, and finally we will run the ffuf full, but with some of the modifications spoken about here. So the word list, we will want to ensure looks like that. So we can delete this, and then this will replace our word list with a file descriptor that is successfully encoding everything to be URL safe. So we're going to match condition to 200. We're going to follow redirects. We're going to set some of the cookies. So security low, PHP session ID is what we've just created there. And then the word list for a file handle to be pen code encoded for the payloads. And then we're going to output that into a directory. So each request gets outputted into a directory. We can let that run and then see what it returns. Awesome. So all 114 items return something. So we can have a look at the output directory. Is it out reflected? There we go. So these are all the files that were just created. There should be about 114 in them. We could quickly do a word count. 113. Cool. So they've all worked successfully. Now we can, so they're just MD5 hashes of the files, and then each MD5 hash would be different from each other because it includes the timestamp at which the command ran. So that differentiates them. This is the Python script we will be using. Before we look at the Python script, you will need the Chrome driver and Selenium Python packages installed. So if you try to install Selenium, you'll be greeted with an error message. I highly recommend Jeff Geerling's blog. He's got some great resources. In this instance, it was from him that I found the way to bypass this. So the Python maintainers in their infinite wisdom have made it much more difficult to install packages in the global installation, but this is a VM. I don't really care if it breaks. I just want it to work. So instead, you have to delete a specific file. Once that file is deleted, then you're good to go. Again, you want to make sure what version of Chromium that you have. You download the correct Chrome driver for that version. So here it gives you the installation steps to be able to accomplish that within your environment. Once that's all done, you can come back to this guide and then we can go through the Python code. Okay, now that you have the Chrome driver installed and you can actually install other Python packages, we can proceed with the code itself. I'm going to copy this from the web page. It's not in Git or anything like that because we don't want to overcomplicate things. Vim and then xss.py. Then this will make the file. We'll go into insert mode, Control-Shift-V to paste everything, and then I'll just go over it with you quickly. We're going to want to, again, import the argparse, import OS, import time, glob for some of the fuzzing stuff, concurrent features. So then this allows us to kind of make it a bit more multi-threaded as opposed to just one thread, and then it works away at the 114 requests. That just takes forever. And then from Selenium, we want the web driver, and then we want some other imports. So we'll be able to successfully interact with the headless web browser. Then we also, the TQDM allows us to plot this on a nice progress bar easily and nicely. It's a great package, very powerful for progress bars. We have, again, our pass arguments. If you've seen the last video, you'd understand what we're talking about here. No, not the last video, the one before that, which was the SQLi blind, where we talk about pass arguments. Great package. Getting that function does that. Then the create driver, this is required by Chromium to create the driver. So headless, and then where the Chrome driver is installed. You might need to update that depending on your specific setup. We can then, as opposed to doing this previously, I've got a function now to rename and modify all of the files within the directory that we're targeting, so that they'll all be HTML files, because they're not, if the file doesn't end in .html, Chrome driver doesn't understand it, and it's just like, I mean, Anyway, we rename all of them, great, and then we also remove some stuff that ffuf leaves behind so that it's actually properly commented out. So when you open it in Chromium, it correctly displays. We will then check another function, check for cross-site scripting, and then pass the argument file path. It will then it's got to try accept to attempt the cross-site scripting on that path. Finally, you got your main. That gives you all of the other information. And then this is for the concurrency so that you can run multiple threads of this process as opposed to just going through one at a time, very slowly, paying some of the shortcomings of Python, but it's a story for another day. We will now run, if we look at the ffuf directory, they all end in .html because I've run the script before. Hopefully running it again, it doesn't clobber the .html again. That'd be a pain. But now that the file is written, we could do a Python 3 and then the file name and the directory you want to target. It will then load that all and with the concurrency run these checks in batches as opposed to individually. You can see the processor is ramping up. Normally Python would be one at a time. But this could be rewritten in Go and actually have real concurrency. Although, I mean, it's just a little Python script for a blog post. I mean, you know, a time and a place. And we're over halfway done. Then again, this progress bar is provided by that TQDM package. Very powerful, great piece of kit. I've used it a few times for media encoding. Let's say that transcoding from different codecs into something that's actually supported by PS4, but it's neither here nor there. This will then give you a list of files that actually will generate an alert. So for instance, we have this file here. We can then do a Chromium pull out the reflected and then paste the file name, and we should be greeted by an alert. There we go. So that payload successfully runs and generates an alert. We can then look at what that payload is with another sort of grep command. Here, head n1, and then the specific file name that you're targeting, and then a grep. So we will call this, because I'm lazy, I will delete it, and then with the bang command, bang $, will be the last argument of the previous command. And then we can see, okay, that is the cross-site scripting payload that will actually fire against the web server. Great. And that's, if you wanted to look at the files themselves, you can, of course, vim and then out, and then I'll just copy this one. That would double directory it, which we don't want. This is what the file actually looks like. Again, this comment stuff is needed so the browser renders it and it doesn't get confused. This is just leftover information from ffuf. It gives you a sort of connection processing stuff, so the request and then the response. But we want it to be actually only HTML so it doesn't confuse the browser. Anyway, that's pretty much all there is to the scripting side of it. We can then go to the blue team perspective to see how we would successfully detect this activity, because in this instance we can actually detect it. And now for the blue team part of this guide, where we'll be discussing how to successfully detect the activity that we have undertaken throughout the red team portion. Again, you're going to want to get the prerequisites, so the seam must be enabled and must be logging correctly, all of that, if you want to follow along at home. If not, you can just have a look at this part of the video and it'll give you an idea as to some of the detection methodology that you could use in your own enterprise or in your own environment. Again, we are lucky in this case that all of the requests happen through the get method so that it is actually logged within the Apache access. If it was using the post method, we would be out of luck. Instead, we would have to then employ a WAF like mod security or a more modern WAF. The Sigma rule to detect this is looking for the script tags. It's an existing Sigma rule that I've just converted into a correlation rule that looks for the script tags. We can then load Elastic quickly. Well, I say quickly. It takes some time. Logging in and then having a look at the particular information. We want to look at alerts because I've just recently ran all this activity. It should be within the alerts pane if all's gone well, which it has. Cross-site scripting strings. Awesome. We can then look at the definition of this rule. If I wanted to move me there, you can then see all of what's going on here. The ESQL that we're looking at today is from Apache Access Logs, blah, 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 where request method get. In this instance, would head-based obfuscation work? Because it would be in the response body, would it? Head and post-based obfuscation may work in this instance. Could be interesting to try, which we'll be trying on in the medium posts. And then just the query strings like these sort of indicators here. So script. There are some weaknesses to doing it this way. If you've split up script or if you're camel casing it and stuff like that, I believe like is case insensitive in Elastic, but I'd need to, well, in the EQL instance of Elastic, I'd have to have a look. And then again, where we're doing a filter for not 404 status codes, and then we're telling it to look for the time buckets and the evals and stuff. So the Sigma rule converts it into Elastic works pretty well. And then have a look at the next part of, yes, the XSS tricky. This was interesting to say the least. If you do not correctly make these requests URL safe, it will look like they aren't actually being detected by the seam. That is a weakness and a strength, we should say, because it wouldn't actually work on the server side because it'll just fail as that request is malformed. So if the server is correctly conforming to what should and shouldn't be URL safe, it'll say, hey, that's not URL safe. I'm not even going to process that request. However, within the seam, it breaks the grok pattern that the Elastic parser uses to hoover up the logs from access.log. For instance, by way of example, I ran that entire thing and then we would only get 2 scripts. That was very concerning to me at the time because this is what the logs actually looked like. I mean, there were, how many logs is that? Almost 10,000. It's over 9,000 logs. Like that should really, what's going on here? Instead, it was just an issue with how the Elastic grok parser deals with these particular logs. For instance, that is not URL safe. So it will actually just go into some, due to how the parser is set up within the grok functions, basically, it will just get thrown into TLS handshake error as opposed to where it should properly be. This is very much an edge case. You don't need to worry about it too much, but it's a rabbit hole possibly worth exploring when things don't necessarily work out the way that you would expect them to. So for instance, we could run this same search now against the live data that I've just generated throughout the testing. And let's see if it comes back with something. It should come back with something because don't go to metrics. Why you go to metrics? Why? And it's going to make me log in again. I haven't quite figured this one out yet. Maybe one day. Logs there. and then shoot. Awesome. Now we see much more, 36 that have script or script in them. Very good. We can then look at this individual one, and the URL actual target will be URL original. We'll make that into a row here, and then we can see exactly what's going on. And then all of these were attempted. Whether or not these were successful, that's another story. It's more difficult to tell due to the nature of JavaScript and what's going on. However, we can see that these were all the requests that have been made. Then it is actually correctly searching. So 36 out of 114, I mean, you're looking at, is that almost 40% of them have script or in uppercase or lowercase within them? It's very good, very good. Then there's, again, the Nasim no problem for this instance would be just looking at the Apache access logs. So doing a grep for, it's not included here in the blog post, but it'll just be a simple grep in apache.access. Then we can look at the purple team. In this instance, it is relatively simple. However, there are some caveats that we're going to need to keep in mind. So I'll see you in a little bit for that one. And then finally, the purple team perspective for cross-site scripting reflected within the damn vulnerable web application. How can we automate these processes and these attacks so that we would be able to successfully test for their existence and test that the detection or prevention is working correctly? Again, nuclei is the first port of call when trying to automate some of this activity. We can hit it with a headless. Again, is required because the detection actually happens within the JavaScript engine. So without that headless, it's much more difficult to be able to 100% say, yes, this attack is actually working correctly. Again, because it's rendered within JavaScript. We could run this payload. It successfully finds 2 matches. Great. Then we want to have a look at this payload. So to have a look at it, we could just open it up, and then it's very similar to the DOM-based cross-site scripting. Again, we put some variables. We then assign the flow method, HTTP1 and 2 to log in, set security, and then we do a little for loop for the payloads in the payloads array. We test each one, and then finally we will return the results with some matches and extractors so that we can successfully see, yes, this payload succeeded. And then that will be printed to the screen. Nice and easy for you to have a look at. We then want to take that to the next step and automate some of the detection processes. So let's say the rule has changed, you've added in a new parameter and you want to verify that it's working correctly. We can CD into the Omega CLI quickly and have a look as to how we would do that. The template file in this instance, again, very simple. However, I've added a new executor to be nuclei headless so that it successfully runs the headless version of nuclei as opposed to just regular nuclei. We can run that with this command here. And then again, with the D flag so that we could see YAML is valid, target is up, the actual commands that we could run if you want to debug in the background, all of that good stuff. You can see that it's successfully found 2 matches. We then will hit the Elasticsearch seam with that specific rule and see, yes, we are in fact getting would in fact generate an alert. If it was real, we would generate that alert. Awesome. So we can successfully test for these within the Omega CLI. And that is all for today. I would like to thank you for joining me, and I will see you in the next one.